Being a multi-billion-dollar healthcare corporation is more than just a financial accomplishment for Abbott Laboratories. It is an important responsibility. It is a responsibility we have towards the customers who use our products and the patients who benefit from them. At the Abbott Diagnostics Division facility outside of Dallas, Texas, we take our commitment to customers very seriously by providing a continuum of service across 4 key areas: engineering, material flow, manufacturing, and customer support. Across this continuum of service, we maintain the highest quality standards in compliance with ISO 9000 and QS regulations, formerly known as GMP. The diagnostic instruments that are designed and manufactured by the Dallas facility include high-volume immunoassay instruments such as the Axim and Prism, the Architect i2000, and benchtop systems such as the LCX Analyzer. From design concept to field support, each area across the Dallas facility's continuum of service contributes to the success of the Diagnostics Division and Abbott Laboratories. Before new instruments are rolled off the manufacturing line, they have first been modeled and many functions simulated in the virtual world. Design engineers and scientists use the latest workstations and software to perform instrument modeling and simulation. The workstations and software are supplied and supported across the division by a central engineering support group known as EMA for Engineering Manufacturing Automation. The Dallas-based EMA group leases CAD/CAM workstations and software to internal Abbott departments. EMA services include continually upgrading hardware and software to the latest revisions, saving our internal customers the expense of purchasing and upgrading workstations and software. EMA even provides software training and phone support to ensure that our internal customers get the maximum benefit from these engineering technologies. All mechanical parts are designed using solid modeling software. Outside suppliers make parts from the models without paper drawings, which improves the accuracy and speed of fabrication. Using the computing power of workstation and software tools, individual mechanical parts are analyzed for different types of failure. This is known as finite element analysis, or FEA. Using FEA software, plastic components are analyzed for potential leaks and other types of failure before the part is even manufactured. With high-powered solid modeling tools, internal and external components of an entire instrument can be assembled on the workstation and tested during a computer simulation. Electrical engineers also take advantage of the advances in design tools. Just a few years ago, engineers relied solely on oscilloscopes and frequency counters to measure the electrical output of a circuit. Today, the function of these measuring devices can be recreated within the computer program. In another area of electrical design, new technology has enabled the Dallas engineers to condense the functionality of an entire circuit board onto a single ASIC chip. ASIC stands for Application Specific Integrated Circuit. Abbott's ASIC Design Group uses the latest tools to efficiently design and simulate these complex microchips. Since ASIC chips reduce the number of circuit board components by 75%, they are used in most Abbott instruments to reduce cost and avoid problems that arise when larger components are no longer manufactured by an Abbott supplier. By enabling engineers to test and modify an instrument's mechanical and electrical design before the individual components are manufactured, this new technology helps bring Abbott's diagnostic instruments to market as quickly as possible. Prior to production, instruments are subject to environmental and electrical testing. Abbott has invested in the capital equipment to conduct most of these tests on-site. EMC is one of the important tests performed in our anechoic chamber. An EMC test chamber is used to determine how well the instrument is grounded, its susceptibility to electrical interference, and if it causes interference with other instruments in the lab environment. To make these assessments, The EMC tests simulate different voltages and radio frequency, as well as fluctuations and surges in electrical power. When the instrument design has been tested and finalized, purchasing is responsible for ordering parts through Abbott's Certified Supplier Program. All materials management activities must comply with QS regulations. After a shipment arrives in the receiving area, Incoming Quality Assurance, or IQA, inspects new parts sent by Abbott suppliers. Based on the original designs from engineering, components include mechanical, electrical, and molded parts for ADD's diagnostic instruments. A sampling of parts from each new lot is inspected visually. A coordinate measurement machine, or CMM, measures the incoming parts to compare them with the specs from the original component model. If a new part fails inspection, the lot is rejected, and IQA fills out a non-conformance material form. If the part passes inspection, the component is certified and staged in the warehouse staging area before it is sent to manufacturing. A component that already has been certified shipped to stock can be shipped directly to the manufacturing floor. This direct delivery of components to the manufacturing floor is part of the just-in-time inventory system. Inventories are kept low to reduce the amount of space and expense needed to store a large backlog of component parts. When supplies are running low on a particular component, the employee will come across a card which contains instructions on the number of parts needed and when they should arrive. A Kanban automatic order entry system ensures that new components are delivered on an as-needed basis. Materials management is always looking for ways to reduce the cost of incoming materials. The Certified Supplier Program is managed very proactively. Abbott uses its substantial buying power to leverage the most favorable costs. By working with Abbott's certified suppliers to combine vendor purchases throughout the corporation, we can maintain the highest product quality at a low production cost. This is where our design expertise and quality assurance standards literally come together. ADD Dallas Manufacturing. Subassembly begins with the manufacture of printed circuit boards, or PCBs. The circuit components are placed onto the board by automated placement equipment, after solder paste is applied to the board by a screen printing operation. A monitor displays the position of each component, so the part can be repositioned if necessary. The equipment's accuracy is on the order of 1 to 2 thousandths of an inch. The process is completed when the entire PC board is placed in a reflow oven, which remelts the solder to make a connection between the parts and the board. After the components have been soldered, cleaned, and inspected, computers perform automated testing on the boards to ensure they are free of defects and meet quality standards. PC board assembly and testing is part of a much larger manufacturing operation. The Dallas site includes subassembly and final assembly of the Axim, Architect, and Benchtop diagnostic instruments. Using the just-in-time inventory system, instrument parts are delivered to the manufacturing floor on an as-needed basis, where they are used to create larger subassembly components. In the subassembly area, subs are built and tested for different instruments. Specialized computer software tests pipette subassemblies for liquid volume displacement without even performing an actual run. The computer also collects data from these tests and creates a statistical analysis to verify that the subassembly is performing properly. Each step of the product assembly is laid out using video manufacturing instructions, known as VMIs. VMIs use digital photography to demonstrate each assembly step. If any part of the procedure changes, the text and photos can be updated offline and downloaded to the Assemble Station site. After assembly and testing is complete, the subs are placed on racks. Manufacturing personnel pull these parts from the racks for the final assembly. To begin a final instrument assembly, the assembler takes an empty cart and collects all parts and subs necessary for the instrument. They are brought to the assembly area and assembly begins. Some of the subs are large and require lifting equipment to move them into place. The instrument cover, or skin, is put on during final assembly. In the instrument assemble area, different sub-assembly parts are tested. In addition to tests for diagnostic accuracy, the instrument is also tested for user safety. After all of these tests have been performed, the finished instruments are ready to be shipped to a customer. But ADD's continuum of service does not stop here. ADD's worldwide customer service and support provides other internal support personnel with the training and tools they need to assist ADD customers. Customer service and support's primary responsibilities include providing technical and field service support for the service and support personnel who interface directly with Abbott customers, developing customer and service documentation, distributing technical information to worldwide service and support personnel, and communicating any customer issues with manufacturing and R&D. Conducting operations and worldwide service training for service and support personnel, providing assistance with manufacturing operations, and providing input to engineers during product development. Our customer systems engineers, or CSEs, have at least 4 years of field-related experience with medical equipment. The primary functions of CSEs are to provide support for worldwide field service representatives, or FSRs, help resolve critical hardware and system software issues, develop and distribute service documentation, produce instrument reliability and parts usage tracking reports, and track and monitor field upgrades. The customer support technologist's main responsibilities are to provide technical support for worldwide support personnel, help resolve user issues with interfaces, assays, and training, develop, review, and approve customer documentation, and coordinate new product and assay training for service and support personnel. Both CSTs and CSEs share information from the field with different manufacturing and service areas within ADD. From collaborating with engineers to develop products that will best suit the customer's needs, to providing support for field service representatives and support personnel who deal directly with the customer, ADD Worldwide Customer Service and Support maintains our continuum of service from product concept to customer satisfaction. As a leader in the diagnostics industry, ADD is committed to product quality and customer satisfaction. Because innovation is a continuous process, and customer service should extend to everyone who uses our instruments, the Abbott Diagnostics Dallas facility provides quality engineering and manufacturing support from concept to completion and beyond. Because it's more than just our responsibility, it's our guarantee.